So we can see this as our classic dynamics problem. In order to solve the dynamics problem, we need to follow the protocol. So first we need to recognize that this was a dynamics problem, and then we need to draw the free body diagram using the given information. We need to go, oh crap, I don't know how to solve these. These are pretty tricky. But we do know that the summation of forces is equal to mass times acceleration, and we need to figure out which direction that the acceleration is going. Using this and the work energy theorem, we will be able to find the coefficient of friction, the rotational velocity, and the rotational acceleration.
Potential energy goes to kinetic energy in two types. You have the kinetic energy in the linear direction, plus some kinetic energy with the rotation of the wheels.
Tryna catch me riding dirty, tryna catch me riding dirty, tryna catch me riding dirty.
GH equals 1/2 m v squared plus 1/2 I omega squared. So MGH equals 1/2 m v squared plus 1/2 I, which turns into mr squared, and omega, which turns into v squared over r squared. So MGH equals mv squared. Velocity is going to be the square root of gh. Velocity is going to be 10 meters per second squared times the height of 5 meters. So velocity equals 7.07 meters per second.
We know the potential energy is going to convert into kinetic energy, meaning there's going to be a translational kinetic energy and a rotational kinetic energy. So we can write mgh is equal to 1/2 mv squared plus 1/2 I omega squared. We can write v squared as omega squared times r squared. Plugging in the values, you'll get omega as 10.7 radians per second.
So the average velocity is 3.54 meters per second. So we're going to find the amount of time it takes to travel at 4 meters it takes to stop. So you can set the average velocity equal to the change in x over change in t. The time will be 1.13 seconds. So now that we know the time and we know the final, and we know the change in omega, we can find angular acceleration by setting that equal to the change in omega over change in time. I'll get 9.46 radians per second squared.
So what we can say is that torque is equal to I times alpha. We know that torque is equal to force across the radius. And then this force here needed to apply a torque is going to be the force being used to solve for mu at the end. So we know force is equal to I alpha over r. And if we change I to mr squared, plug it in mass and radius, you'll find that force is equal to 499.5 newtons. Force of friction is equal to mu times the normal force. So normal is equal to the cosine of 20 times mg, which is just 80 kilograms, times 10 meters per second squared. Normal force equal to 751.8 newtons. So mu is 0.66, and there's your final answer.